As we head into Lesson 5, we're going to talk about multiplication as scaling. We're going to talk about whether a number enlarges or shrinks based on what it is multiplied by. Fractions can be less than 1 or they can be greater than 1, such as these that are mixed numbers or an improper fraction. And we can have fractions that are less than 1, or we can also have fractions that are equivalent to 1 when we have the same numerator and denominator. Here it talks about enlargement. When we have something and we multiply it by 2, we're getting twice as big, so it's 2 times as great. And you can see that this factor here, 4, doubled in size in the product. The 4 became an 8. This 2 doubled and became a 4. It's twice as big. Here we have 5 times 6. It says the first factor tells how many times greater the product is than the second factor. We can say that 30 pencils are 5 times as many as 6 pencils. In these examples, we have more whole numbers that are multiplied together. And it says, determine or interpret these problems as scaling increments. So we have 5 times 5, which would be 25 is 5 times as great as 5. When we have a mixed number or fractions, we could say 3 halves is 3 times as great as 1 half. All of these are enlarging because the 3 halves is definitely bigger than 1 half because we have 3 halves. Now we can also decrease. It says now the length and width of the rectangle B is half the length and half of the width. You can also say they are 1/2 as great. So as you can see, we have 1/2 times 4. In terms of scaling, you can say 2 is 1/2 the size of 4. When you are doing scaling increments, here we have 1/3 of a litter 3 times. It says there's a litter of 6 kittens in groups of 1/3. 2 of the 1/3 groups, or 2/3 of 6, equals 4 kittens. You can see we didn't take the entire whole because we multiplied by a fraction. So 2/3 of the group is less than the whole. As you continue to go through this lesson, you will see a variety of different models, and remember, it's all about enlarging or shrinking and being able to write that problem as a scaling statement. There is not a lesson checkpoint for this assignment, so it is just more of a review and time to work with your student. There are great videos in LearnZillion that deal with scaling that are very helpful to show the effect. So as you can see here, it says this factor is less than 1 because it's only a fraction. So when we multiply by something that's greater, this is a bigger number, the product is going to be less than this number because we're only taking half of it. If we were to multiply by an improper fraction, the result would have been a lot different. Here we have 1/4 times 8/2. Now that's the same as a whole number because 8/2 would be the same as 4 pieces. 8 divided by 2 is 4. So it says you have the first 1/4, however, many more 1/4 pieces are left to equal 8 halves. In fact, once you simplify the product, you'll have an entire pizza, not just 1/4. So you can see that the product ended up being larger because we multiplied by a fraction that was equivalent to a whole number. It wasn't just a fraction by a fraction. This can be simplified to 4. Here we have a different scenario where we have a fraction by a fraction, and you can see that the product got even smaller. It became 1/6, which is smaller than both of those fractions. The product shrunk in size. Again, there's going to be lots of practice, and then you can head over to the student activity book, and when you click on the book, you can simply go to fractions and then go to multiplication as scaling. And you will see that the most important thing, regardless of the size of the digits, is you want students to really think about what they're doing. For instance, this says which is greater, 6 times 3 or 6 times 3/4? Well, if we're multiplying by a whole number, it's going to be greater. If we're only taking a fraction of the 6, that one would be smaller. Which is greater? You may see these really large numbers, but if we just have 121 times over 10 by itself, or we have it 7 times, of course it's going to be larger if we have 7 of them. Here we have some additional large numbers, but we need to really think. We have 12 33rds, and we have 12 33rds here. This number is 5 halves. That is an improper fraction. That means we have a whole and then a fraction. So if we simplified this, it would be 2 and a half. This one is just a fraction. So if you take a fraction of a fraction, it is going to be less. If you take a fraction and multiply by a whole number or a mixed number, it's going to be larger. Which is less? The same here, we have a fraction by a fraction or a fraction times a whole number. So basically, it is great discussion about what happens, whether something gets larger or something gets smaller based on the type of fraction that you multiply by. And it's also really important to think about what would happen if you're multiplying by a fraction that is also represented as a whole, as one, like 4 over 4. Then the product doesn't stay the same. It doesn't shrink or decrease. So I hope this helps your child be successful with multiplication as scaling, and then we will head into multiplication as division.